Hello student, let's try to understand integrated equation of first order reaction student. So how we represent student, that is R, it is going to, we can write student in the term of the product. So R, it is going to give product student. So when you are writing rate student, so rate is proportional to the concentration of the reactant power how much student 1, because it is first order reaction student. If you remove the proportionality constant student, so it will k, it will come the r power 1 student, right? How we write a rate student? Change in concentration of reactant per unit time student dt is equal to k, it is concentration is r power 1. We can integrate only similar term student, not the different term. So what we are going to do student, we are taking the dr negative term, we are sending the other side student, dr by what student, r is equal to, here is minus k dt. We can integrate this equation student. Okay, here we are going to integrate this equation, dear student, this equation. So if you are integrating this equation, so you should know the rule of integration student. dr upon this is going to be r student is equal to minus k, this is what student, dt. So on integration student, if integration of what student, dx upon x is equal to, it is going to be ln x. This is what is the rule student. So here we are writing ln r student, this is the ln r is equal to minus k, and integration of dt is equal to t. So k, what is there student, t plus it is going to be I. This is I is equal to integration constant student, integration constant, dear student, this is. Now what it, this is the at time t student. Okay, now at t is equal to 0 student, so t is equal to 0, so r is equal to going to be r naught student, r is equal to r naught, right? So here is the one, from 1, from equation what we are going to be student, from 1. So ln here is going to be at the place of r, this is r naught student, minus k, time is equal to 0 plus I. So what will be there student, ln r naught is equal to what is student, I. This is equation number 2. Now what we are going to do student, from 1 and 2, from 1 and 2. So from 1 and 2, here you dear student, you see it will be the ln r only is equal to minus k t plus I value we are putting student, ln r, this is going to be naught. Now we are going to rearrange student, kt we are taking the this side, kt is equal to ln r naught. Okay, and this will go that side student, so it is going to be what student, ln r, right? So dear student, what we are going to kill, ln a minus ln b, so it is going to ln a by b. Okay, this is the rule, you should also simultaneously you can try student. K2 is equal to ln, this is going to be r naught by r. Okay, so what will be there student, ln is equal to 2.303 log. So kt is equal to 2.303, it is log student, right? R naught upon what is student, this is going to be r. Now k is equal to student, k is equal to 2.303 upon t, it is log r naught upon r student. Okay, now this is r naught is equal to what is there student, r naught is equal to initial concentration, and r is equal to what is the remaining concentration, okay, remaining concentration. Okay, this is, now we are going to understand half-life period, half-life period of first order reaction student, first order reaction. So t is equal to, we have to take student t 1 by 2, or and r is equal to what is will be there student r naught by 2. This is there. So dear student, this is suppose equation which can be the equation number 3. So from 3 only we have to derive student, from 3 we are writing from 3, from equation 3. So k is equal to 2.303 upon, at the place of t it will be t half log, what will be there student, r naught as it is. At the place of what we r naught, r is equal to r naught by 2. Now k is equal to 2.303 upon t 1 by 2. Here is log student, what will happen student, this and this will be cancel out, log 2. So k is equal to 2.303 upon t 1 by 2, log 2 value 0.3010. So t 1 by 2 is equal to 0.693 upon what student, k. This is the half life period of the what student, first order reaction, right student. Now what we should try to know student, we should know the graph also student. So graph, let us try to understand the graph student, graph. So case 1 graph, many graph are possible student, ln r versus time student, versus time. So ln r versus time, which equation can we use student, ln r, this y is equal to mx plus c, this equation we can use student. Okay, ln r is equal to minus kt, here you see ln, this is r is equal to minus kt plus, you see student what is there, ln minus kt plus ln r naught, minus kt plus ln r naught, this we can use student. So y is equal to, this is the mx, what will be there student, this is the mx plus c. So dear student, you can take the x axis, this is x axis, so here will be the time, and this is y axis, so there will be the concentration of, dear student, this is the c, intercept is there na. So c, if this is the intercept, so at the c what is there, ln r naught, this is the ln r naught, here on the top student, ln r naught, this concentration. And since the slope is what is there student, see slope is negative, so it will go the downward student, downward. So if you are writing slope is equal to minus k, right. So this is what is the equation student. This graph is what student, graph between what is student, ln r, okay, ln r versus what is that, is time. Now we have to see the graph student, one more graph, case 2 we are going to be, case 2. So ln r not r versus what is there student, we are going to take the time, not ln, actually we have to take the log student, log. So which equation can we use student, this one, check back students, if you are using this one, we can use here this equation student, this equation we can use student. Okay, so let us see the kt is equal to 2.303 log r naught by r, kt is equal to 2.303, okay, kt is equal to 2.303 log r naught by what is there, r student, this is there. Dear student, what we can do here, if you are writing this equation, so you can log r naught by r, you can take r naught by r is equal to kt upon 2.303. So this is y is equal to what is there, mx plus what is there student, see this is the mx, not xx student, this is the mx. So dear student, if you are writing like this equation, so dear student, what will be there, time is going to be x axis, dear friend, x, this is y axis, okay, m is what student, this is the and negative sign is there or not, that we have to check out, student. Is there negative term? Are there? No, there is no negative term, student. Okay, so it will be there the same way, student. Let us try to draw here. This is, student, x-axis. This is the time, student, because it is x-axis. This is the y-axis, student, so it will be the log. It is going to be r naught by r, dear student. This is there. Now slope will be the positive, student, dear student. Here slope, so slope is equal to what is the, student, k upon 2.303, positive is there, and c intercept is 0, so it will be start from the 0, student. So this is what the second case, student. Now is there any other cases? No, student, this is what the case are there, student, right? Half life also we have done, student. Thank you very much for watching, student. Huh. From here we have done.